Foxtech provides value-added corrosion and pipeline monitoring solutions for the oil and gas industry. We offer a comprehensive array of products and services focused on refining, gas plant, upgrader, and many types of pipeline monitoring applications. Our headquarters is in Toronto, Canada. The green markers indicate our regional offices in North America and overseas, while the highlighted areas show countries with Foxtech system installations. The FT system measures pipeline bending, compression, elongation, and strain linked to events such as earth movement, including landslides, riverbank erosion, unstable permafrost, and even earthquakes. Steel, concrete, or composite pipes carrying oil, gas, water, steam, or chemicals all can be monitored. Data may be gathered periodically or on a continuous basis. Soil movement can also be monitored, alone or at the same time as possible pipe deformation. Remote telemetry and alarm output capability allow linkage to control systems. The system consists of three major components: non-intrusive, non-electrical fiber optic sensors selected to match the application, a portable or dedicated monitor, and Foxtech's DMAT data storage, analysis, and reporting software. Fiber optic sensors are the heart of the system. The fiber is the same as that used in industrial telecommunications. Glass fiber is tough and easily managed in the field, using all of the proven tools installers and field technicians employ. Fiber optics do not interfere with cathodic protection systems, inline inspection pigs, or impulses in the pipeline from non-direct lightning strikes. The FT monitor is engineered to be rugged and portable, or else be installed in hostile environments to report continuously. The monitor operates on the established principle of low coherence interferometry to measure minute changes in the length of a fiber optic sensor. Proprietary methods are used to send light from a broadband LED out to the sensor and also to reference markers inside the monitor. The return light from both locations produces interference signals, which precisely determine the length of the sensor. The sensors have a resolution of about 1 micron, which is equivalent to a few millionths of a meter. Foxtech's DMAT software stores data and uses algorithms to convert raw strain readings into usable bending data, graphics, and alarm outputs for analysis and control. Pipeline bending and elongation is measured by bonding several fiber sensors onto the exterior surface of a pipe, along with a fiber optic compensating temperature sensor. In the field after application, the sensors are overcoated with normal pipeline materials such as wrap or insulation linings. When a pipe moves, the fiber lengths are compared to initial baseline readings, and the geometrical relationship of the fibers allows the magnitude and direction of bending to be computed. Let's watch a system in action using DMAT software. Shown here are a portable FT monitor and 1 meter of exposed sensors on a 3-inch ABS pipe for ease of handling. The pipe section has 4 sensors, 3 to report bending and 1 to report temperature. When the pipe is straight, low strain is shown on the upper DMAT graph. The red points are calculations made immediately after the sensors are interrogated by the monitor. To show the sensitivity and immediate reporting, we add a 3 kilogram or 7 pound weight onto the pipe. The tube only deflects about 1 millimeter or 4/100ths of an inch. DMAT software shows the increase in bending strain and the reference direction of the bend in degrees. Applying a heavier weight produces immediate higher strain readings and an alarm. FT bending systems have been in field service for several years. Here are some key installation and commissioning steps using data from several sites. The location of concern is determined from pipeline risk models, topography, or the mitigation site plan. If needed, the pipeline is dug up and the pipe is exposed. The external and internal coatings are removed, so the bare pipe is exposed. Because the sensors are non-intrusive and non-electrical, no shutdown or derating of operation is required. Sensors are unpacked and fitted for placement, then glued on with a field-rated 2-part epoxy. To capture bending and ensure that strains are picked up, Foxtec uses sensors from less than 1 meter to several meters in length, depending on the application's requirements. The sensors are overcoated with protective materials, and the pipeline coating is applied. The low profile of our sensors means easier backfilling. If the installation requires a dedicated monitor and telemetry, the sensor lead cables are routed to the monitor and installed. The entire system is checked for operation and signed off. Data flows to Foxtec's data center for analysis and reporting using DMAT. Soil movement measurements along with pipe bending can be very helpful to give a total picture of the situation in the field. The FT system is the only product that measures both pipeline and soil movement at the same time, with easy integrated reporting. Here is how the soil movement system is installed and operated. FT bending sensors are attached to a section of standard slope inclinometer plastic tubing. The tube is inserted into a borehole and placed at a depth where soil transition is suspected or observed. As the sectional tubes are installed, the lead cables are brought to the surface. After installation, the hole is grouted with cement. The lead cables are inserted into protective conduit and run to a breakout box, where each sensor cable is terminated with a rugged fiber optic snap connector. The breakout box can be up to 2 kilometers away, allowing for convenient access. Measurement is simple if periodic visits are being made several times a year. Patch cables for the sensors are connected to the portable FT monitor and to the breakout box. Data is then taken and analyzed. Fiber optics to measure soil movement means that tubes can bend a lot. Higher dynamic range and no moving parts means a significantly reduced need to re-drill boreholes for replacement tubes. Measuring both soil movement and the response of a pipeline to soil movement gives a complete picture of field conditions. The FT system is a major advance, allowing pipeline operators to obtain early warnings about developing situations before they become emergency situations. Data from sudden events such as a landslide is reported as pipeline strain, which precedes a rupture. All of this is done without hydrotesting or other operational disruptions. Non-electrical sensors do not fail in moist soil or because of interference from electrical impulse energy. Fiber optic sensors have a much higher dynamic range compared to other types of systems. Longer length sensors mean more reliable pickup of strains. Non-electrical sensors mean longer field life and less redigging. Easy access or remote telemetry saves manpower and money. Periodic monitoring can switch to a continuous mode if needed by placing a remote monitor with solar panels and telemetry hardware on site at any time. DMAT software provides precise trending, alarming, and analysis capability. Reporting is rapid and quantitative. Any mitigation needed can be scheduled in advance, reducing maintenance costs. All of these features together mean enhanced integrity, leadership in regulatory compliance, and outstanding protection of the environment or urban areas. For further information,